Okay, so you need to understand right triangle trig, the basics of solving problems with sine, cosine, and tangent in right triangles. First, in this video, I'm going to show you how do we do this with a quick example, because a lot of you, that's what you're looking for. But I always want to focus on understanding math. So after we do an example problem, I'll go back and explain what actually is this? What are sine, cosine, and tangent? What does it mean when you write those down? What is your calculator doing when you put that in there? How does this actually work? Because I think math is best when it actually makes sense, okay? But first, for those of you who just want, here's how you do it, you're trying to get your homework done or whatever, got a test tomorrow, let's jump straight into that. So first of all, when do you use it? You have to have a right triangle. Has to be a right triangle. And you have to know at least one of the other angles, one of the acute angles. Let's just say that we know that this one is 20 degrees. Then, you also need to know at least one of the other side lengths. Let's say that we know that this side is 10 units. And then let's say that we're trying to figure out the hypotenuse, because that's the other thing. You need to be trying to figure out a side length. Although you can use this to figure out angles if you know the sides. I'll do that in another video called inverse trig. Okay, this will be focusing on solving for a side length when you know one of the other side lengths and you know one of the other angles in a right triangle. So this is basically how you do it. Now, step one, right? So if we want to make this a step-by-step process, step one is to identify your sides. Okay, identify sides. Now, what do I mean by that? Sine, cosine, and tangent are ratios of sides in a triangle, and they're usually called the opposite, adjacent, and hypotenuse, okay? You need to identify which side is which. Now, the opposite and the adjacent depend on which angle you're gonna use. So in this case, we'll say we're referencing from the 20-degree angle, although if you wanted to, you could figure out the missing one since the angles in a triangle add up to 180, and you could use that one instead. The problem will look different, but still get the same answer. But let's not get hung up on all that. How do you identify which side is which? I've taught this years and years and years, and I've figured out that this is an issue for a lot of people. For a lot of people, figuring out which side is supposed to be which is a challenge. I've got a method that works for every single student, every single time. Start by doing this. Identify the two sides that create your 90-degree angle. Two sides form an angle, right? Those two make that 90. There's one other side in a triangle. Triangles have three sides. The other one that is not one of the two creating the 90 is the one that you should label H for hypotenuse. Okay, it's the one that is not one of the two creating the 90. Remember, you can always pause this video if you need to, or if you want to write some extra notes for yourself. I'm going to use another color here. And now here's the next step. Identify which angle you're going to use. In this case, we're going to use this 20-degree angle. But like I said, if you knew the other one, you could use that one too. But you have to pick one. Pick one of the angles that's not the 90 and identify which two sides create that angle. Okay? Now, there's one side left over in this triangle that is not one of the two creating the angle that you pick. That one is the angle that's considered opposite from there. That's the side that's considered opposite from this angle. So we're going to label that side opposite. Now, if you've successfully done this, and every single one of you can do this, identify the two sides that make the 90, the other one's the hypotenuse. Identify the two sides that create your angle, the other one's the opposite side. Now there's only going to be one side left over, and just call that side the adjacent side. Technically that means next to, and it's the side next to your angle that's not the hypotenuse. But if you just identify the hypotenuse and the opposite side first, the last one left over is adjacent. This is step one. Do this every time when you're first learning how to do these if you're having trouble. Because now we just need to identify if it's sine, cosine, or tangent. So step two is identify if it is sine, cosine, or tangent in this problem. That is step two. How do you do that? Okay, well first, you have to figure out which side do you actually know. In this case, the side that we actually know is the opposite side. If you knew two of them, you could just pick one of the two that you know, okay? And it won't matter. Then identify which side you're trying to figure out, okay? So you do step two by identifying which side you know and which side you're trying to figure out. You'll notice that is two out of the three sides. In this case, it's the opposite and the hypotenuse. Then you have to have either memorized or in your notes. So you have to either have notes or memorize. Okay, this has to be either in your notes or memorized. The ratios for sine, cosine, and tangent. Sorry, I made my screen move there. Okay. Now, what are those ratios? Okay, well, sine of an angle is defined as the ratio of the opposite side divided by the hypotenuse. Okay, the cosine of an angle is defined as the ratio of the adjacent side to the hypotenuse, and the tangent of an angle is defined as the ratio of the opposite side to the, oops, not the hypotenuse, guys. I hope somebody caught me on that while you watch that. Teachers do make mistakes. I caught it, though. Okay. All right. So a tangent is the ratio of the opposite to the adjacent side. Notice that each of these uses 2 out of the 3 sides in your triangle. So the trick is to have this in your notes or memorized. A lot of teachers will have you memorize it as SOHCAHTOA. There's other ways to memorize that as well, like, is this appropriate? I don't know. Some old hippie caught another hippie tripping on acid. There's lots of other ones, but that's one that my teacher told me a long time ago that stuck in my head. Sorry if it's not super appropriate there. Anyway, the point is that we've got 2 of the 3 sides in each of these is being used. So like I said, we identify that in this problem, we are using the opposite side and the hypotenuse. So just find which one uses those 2. Tangent uses opposite and adjacent. That's not what we want. Cosine uses adjacent and hypotenuse. We want the hypotenuse, but we don't want the adjacent. Sine uses opposite. That's one of the ones we needed. And hypotenuse. That's one of the ones we needed. So that is how you identify which one you need. Okay, it's that simple. You can get this right every single time. Now, step 3, right? Step 3 is just fill in the formula and solve. Okay, that's it. Fill in the formula and solve. That's all we've got to do from here. So what do I mean by fill in the formula? Take your formula, okay, and then fill in the blanks. We've got sine, and then we fill it in with our reference angle, the angle that we identified the opposite side based on. That, in this case, is 20 degrees. Then it equals a fraction. Just look over here. It tells you. Now, one of the most common mistakes I see my students make is put the opposite side in the hypotenuse and they flip them around. They put them in the wrong spot. Well, you have to have this memorized or in your notes. Just look at it then. Opposite goes on top. That's how your calculator's programmed. That's how this is defined. You have to do it that way. We've already identified, if you labeled sides first, like I suggested, that the opposite side is 10, so this is as easy as filling in the blanks. And the hypotenuse, we've already identified as x. So again, it's just as easy as filling in the blanks. So here's our problem to solve. Okay, so fill in the formula. Now, the last step, which I guess this could be step 4 kind of, right? So step 3 is fill in the formula. Step 4 is actually solve it. So now, how do you actually solve this thing? Okay, now not everybody's gonna want you to do it this way, but I found for my students, they generally already know a shortcut called cross multiply. And they can do it right every single time if they cross multiply. So I'm gonna suggest doing this as cross multiplication. And I could show some other ways as well. But if you wanna do this as cross multiplication, you can just convert this into 2 equal fractions by putting a 1 on the bottom of sine 20. That's fine because dividing by 1 doesn't do anything. We have not changed the values. These 2 things still are equal. Now, cross multiplication is simple. You do the top of one fraction times the bottom of the other, and write down what you get. You get x times sine 20 in this case. And then that is equal to the bottom of the other one times the top of the other one. That's 1 times 10 is 10. You can start out that way every single time. Now, sometimes it'll be a one-step problem. Your x will be by itself. That'll happen if the x was on top, like if the 10 and the x were flipped around, like, right? Then you would have just got x by itself in 1 step. But in this case, it's going to be 2 steps. This is a link with multiplication. Sine 20 is just an ugly decimal that your calculator's storing for us. We'll deal with it at the end. So how do we deal with it from here? We want to get x by itself. We need to get rid of being multiplied. If this was 2x, what would you do, right? If this was 2x, wouldn't you just divide by 2? Well, sine 20 is just a number like that being multiplied with your x. So all you're going to do is divide both sides by sine 20. Sine 20 is just a number. That's all it is. And when you do that, that reduces to 1, and we're left with x equals 10 divided by sine 20. If you want an exact answer, that's it. That's your exact answer. But usually, since I have no idea how big 10 divided by sine 20 is, we're going to want to turn that into a decimal, in which case you'll need a calculator. I'm just going to use the one on my phone. If you're using the one on your phone, you probably need to rotate it sideways to get your sine, cosine, and tangent buttons. And I'm just going to type in 10 divided by sine 20. And let's see. So I get 29.23804400016, blah, blah, blah. Now your problem might say something like round to the nearest tenth, or round to the nearest hundredth, or round to the nearest thousandth. Let's just say it says round to the nearest hundredth. If I want to round to the nearest hundredth, that would be the tenths and then hundredths, right? That 3. The number after it is a 5 or bigger, so we would round this to about 29.24. And that would be our approximate answer here. Okay, guys, that's the entire process. There's your example. I guess if all you wanted was an example, then quit out of the video now. But if you want to see why and how does this actually work, stick around real quick. So I want to explain, what is this actually doing? What is your calculator actually doing when you press the sine 20 button? That's the bit that I want to explain. So what is this? This is actually similar triangles. When you start out a problem like this, you don't actually have enough information to solve it. Just knowing the 20-degree angle, the 10, and the x, and the 90 was not actually enough information to figure this problem out. So when you're pressing the sine 20 button, you're actually telling your calculator to look up a ratio of sides, a ratio of the opposite side of the hypotenuse, in a triangle similar to this one. Remember that similar triangles always have equal ratios, okay? So the ratio of the opposite to the hypotenuse in this triangle is the same as the ratio of the opposite to the hypotenuse in a triangle that is similar to this one. Similar triangles will have matching angles. So by typing in the 20 degrees, right? So when you type in sine 20, what is your calculator actually thinking? Let me kind of write that over here. So when you type in sine 20, what is your calculator actually thinking? Okay, so pressing the sine button is telling your calculator that you want the ratio of the opposite to the hypotenuse. By typing in the 20, you're telling your calculator that you want a triangle with a 20-degree angle. And because these are programmed to only be done in right triangles, we already know that it has a right triangle, right? That it has a 90. And then it's assumed to also have a 90, right? So it's assumed to also have a 90-degree angle, okay? So basically, your calculator, right? Your calculator, what is it doing? Well, what is our calculator thinking when we push this button? Your calculator is basically being told that you are doing a triangle that has a 90-degree angle in it, because when you press one of these buttons, it's automatically assumed that there's going to be a 90. When you press the 20, it's being told that there's a 20-degree angle in this, and now it passes an angle-angle similarity test, right? There's different similarity conditions. If triangles have two angles the same, they are similar. So it now has enough information to identify a triangle similar to yours. Then, like I said, when you press sine, you're doing the opposite and the hypotenuse. So your calculator is thinking about the side opposite from the 20. That's why we had to conform to those ratios, because it's programmed to think of it in a certain position. And it's thinking about the hypotenuse, and it's thinking about, in its triangle, what does it get when it divides the opposite by the hypotenuse. Now, your calculator is actually calculating this a different way, but this is how you can conceptually understand how this works and what your calculator is doing. So if you press sine 20, so I'm actually going to do that right now. So sine 20, if I round it, it's about 0.342, okay? So sine 20 comes out as about 0.342. Well, how could you think about that? Again, this isn't really exactly what your calculator's doing, but here's kind of how you could think of it. Basically, imagine that it has a triangle that has a 0.342 on this side and a 1 on the hypotenuse side. And it's basically just doing the opposite divided by the hypotenuse, and it's getting that ratio of 0.342 over 1. And when you're solving your triangle over here, right, it's similar to that, and your triangle has a ratio of 10 over x, right? Your triangle has a ratio of 10 over x. And then you're just solving this. This is just a similar triangle problem where we have corresponding side ratios. That's all this is. It's really just a similar triangle problem. All right, so that's more about why this works. Obviously, we could get more in depth, but hopefully now this is a bit less of a mystery, and you have a good idea of how this works. Once again, to wrap it up, as far as just how to do it, identify your sides, opposite, adjacent, hypotenuse. There's two sides that create your 90. the other one is the hypotenuse. There's two sides that create the angle that you type in your calculator. The other one's the opposite side. Whichever one isn't those two is the adjacent side. Circle the side that you know and the side you're trying to find out, and identify that in your list. Which of these three uses those two? Then copy the formula down, but fill in the blanks with the values from your problem. And then if you'd like to solve it by cross multiplying, that's a nice convenient way that's going to work every time. But there are other ways to just solve those problems with normal algebra steps as well that don't involve cross multiplication. All right, guys, hope this was useful for you, and I hope you have an excellent day.